Hello, good day, Eugene. I'm Kathleen Talpe, a UPLV student and also your classmate in Math. We are here today to talk about how mathematics is used in the field. So before we start, will you please introduce yourself and what program do you study?
Hi, Kathleen. Nice to meet you. I'm Eugene Castro, and I'm currently taking up BS Computer Science.
So far, how was it?
It's been quite challenging, but also rewarding. And this is what I can say about computer science. Computer science is a fascinating field that covers a wide range of topics from fundamental concepts like algorithms and data structures to practical skills such as programming and software development.
But let's focus on the concept of logic, the Boolean logic specifically, and how this concept is applied in your field. But first and foremost, what is logic? So logic is defined as the study of the laws of thought or correct reasoning. It pertains to the thought processes that have been established as leading to valid solutions to problems. George Boole invented Boolean logic. He is a British mathematician and logician. So the Boolean logic that he created serves as the foundation of computer science, which led to the application of Boolean algebra. So regarding this, what are your thoughts, Eugene, when you have come across this concept for the first time studying computer science?
When I first encountered Boolean logic in my studies, I was intrigued by its simplicity and power. Boole's creation provided a systematic way to present and manipulate logical propositions, which are essential for solving problems in computer science. It was fascinating to see how these logical principles could be applied not only to design algorithms and create efficient data structures, but also to reason about the behavior complex system and networks within computer science. Boolean logic forms the backbone of decision making processes in software development, enabling programmers to construct logical flows and conditions. Overall, delving into Boolean logic revealed to me its pervasive influence across various domains of computer science and its indispensable role in shaping the digital world we live in today.
How do you implement logic in computer science, especially in coding that plays a huge part in debugging? And how this helps you as a computer student?
While in computer science, logic plays a fundamental role in various aspects, particularly in the design and analysis of algorithms and programming languages. We implement logic through the use of logical operators such as AND, or, and not, as well as through Boolean algebra. These logical constructs are extensively used in coding to control the flow of program execution, make decisions, and perform data manipulation. Understanding logic is crucial for writing correct and efficient code, as it helps us reason about the behavior of programs and identify and fix errors during debugging.
So, what is the purpose of implementing Boolean algebra in what you have said, making designs, analyzing algorithms, and programming languages?
So, the purpose of this implementation is to ensure that computer systems can perform computations and make decisions based on logical reasoning.
And how important is the use of mathematics in this application or implementation?
So para sa akin talaga, yung mathematics is essential in computer science, especially when it comes to logic. Because without a solid understanding of mathematical concepts, it would be impossible to design algorithms and develop software. Also, mathematics provides a precise framework to reason about the correctness and efficiency of algorithms and systems.
Mathematics is really that important, no? So, what do you think is the mathematical background needed to understand or appreciate this application or implementation?
Well, for me, to fully understand and appreciate the implication of logic in computer science, a solid foundation in mathematical concepts such as algebra, logic, and discrete mathematics is necessary. Familiarity with Boolean algebra and truth tables is particularly important for understanding how logic operates and how they can be combined to perform complex computations. Additionally, knowledge of mathematical concepts like sets, relations, and functions is essential for algorithm design and analysis.
So, very informative and fruitful discussion we have today in the application of mathematics, especially in computer science. Thank you so much, Eugene, for everything that you shared regarding how logic is applied and its importance in how computers process information, make decisions, and execute calculations. Again, thank you and have a nice day ahead.
Thank you, Kathleen.
Good day, Miss Ali. I am pleased to have the opportunity to have this meeting with you. I am Tanya, your interviewer for today. I'm a student from UPLB, majoring in computer science. I would greatly appreciate your input on the implementation of mathematical logic and principles in the field of conversion strategy analysis.
Good evening, Tanya. I'm Elisa Santos. I'm a mechanical engineer by profession, and I currently work as a conversion strategy analyst for a multinational business process outsourcing company.
Thank you, Miss Ali. What is your motivation for pursuing a career in conversion strategy analysis?
Well, for me, the beauty of being a conversion strategy analyst lies in the thrill of unraveling the intricate web of data to uncover insights that drive real change. So there's something deeply satisfying about delving into analytics, piercing together customer behavior patterns, and then crafting the strategies that not only boost the conversion rates, but also resonate with people on a personal level, if that makes sense. So the logical aspect comes into play when analyzing data to identify patterns and trends. So it involves employing logical reasoning to interpret the information that we gathered, and it enables me to make informed decisions and recommendations based on evidence rather than intuition.
That's a good way to put it, Miss Ali, and I couldn't agree more. For you, how would you associate the importance of logic in your daily life, specifically in decision making as a conversion strategy analysis yourself?
Mhm. In my daily life as a conversion strategy analyst, logic isn't just a tool that I use. It's actually the backbone of how I approach every decision that I make. So every day brings its own set of challenges, right? But logic is my companion in tackling them head on. So whether it's a sudden drop in the conversion rates or a technical hiccup in our tracking systems, logic helps me break down the problem, identify the root cause, and then devise the solutions that gets us back on track. So as much as we'd like to believe that it can create solution for everything, not every decision that we make will lead to success, right? So that's where logic comes in, actually helping us assess the risk and rewards of each choice that we face. So by weighing the potential outcomes with a clear, rational mind, I can make informed decisions that minimize our exposure to risk and maximizing our chances of achieving our goals.
On a scale of 1 to 10, how important is logic for you?
Well, logic is absolutely crucial in my role as a conversion strategy analyst. So it's like the secret sauce that makes everything come together. So without logic, I'd be lost in a sea of data, unable to make sense of anything really. So it's not just a helpful tool, it's the backbone of how I operate. So with that in mind, I would say 10.
Thank you so much for showing us the importance of mathematical logic and principles, Miss Ellie. I never really thought about how we depend on logic in our everyday lives until now. Thank you for allowing us to realize this. We appreciate having you here, Miss Ellie.
Thank you for having me, Tanya.
Thank you so much. Bye.